Hi, good morning. This is the last part of chapter 14. And here we are going to talk about heat transfer methods. We have three major um, heat transfer methods. The first one is conduction, and that is in solids. This is say you're gonna have a wall that have an insulating material inside, an example on that. Then this is, let's say the room is gonna be at temperature T1, and this is really the environment outside, which is gonna be at T2. And that material has a cross-sectional area, um, or like the contact area as A, and also it has that, let's say, width or thickness D. Okay, Q over T, it is heat heat transfer rate because it is divided by time. Okay, sometimes we call this variable as h, okay, in some of the textbooks. Okay, equals k here, it's a constant called conductivity. A, it is the contact area. T2 minus T1, it is the difference between the two temperature, and D, it is the length or the distance or the thickness of that material. Of course, K is different for different materials, depending on which material I'm talking about. I will show you right away how we are going to use this. Calculate the rate of heat conduction through house walls that they are 13 centimeter thick and have an average thermal conductivity twice that of glass wall. Assume that there are no windows or doors. The surface area of the walls is 120 square meters, and their inside surface temperature is at 18, while their outside temperature is 5. Okay, then here I have D, 13 centimeter. I need to convert this into meters. K, this is the conductivity, the thermal conductivity. Usually this is either going to be given to you or the table is going to be given to you. A, it is 120, and this is delta T. And then I plugged in my numbers, and then I have 1.008 10 to the 3 watts. Now, how many 1 kilowatt room heaters would be needed to balance the heat transfer due to conduction? Of course, if I have, this is actually 1 kilowatt, and therefore, in order to balance it, I need to have 1 kilowatt room heater. The second method of heat transfer, it is convection, and this is in fluids. Fluids mean gases and liquids. And actually what's happening here is if you start warming up using anything, is gonna create currents up. And why these currents they gonna be created? Because this is gonna be warm material, then it's gonna have low density. Low density is gonna go up, and then it will push the cold material down, and then we're gonna have currents up, currents down, and then the heat will be transferred throughout the fluid. Now radiation, it is the only one that we know we don't need a medium for the heat transfer. And again, the heat transfer rate is going to be equal a constant called Stefan Boltzmann constant, which is 5.67 10 to the negative 8. E here, this is related to the surface. We call it emissivity, and that is related to how efficient it is emitted the radiation. And this number can be from 0 to 1. A is the area, and T to the 4 is going to be the temperature. The temperature here should be in kelvins. If I have the object emitting and receiving energy at the same time, then I need to subtract the two temperatures, and this is the equation. At what net rate does heat radiate from a 275 square meters black roof on a night when the roof's temperature is 30 degrees Celsius and the surrounding temperature is 15? The emissivity of the roof is 0.9. Of course, I should write my equation first, and then I will plug in my numbers. Remember here, okay, T2 is 15 plus 273, and this is, and T1, it is 30 plus 273, and that is going to be 303 Kelvin. And don't forget these temperatures, they should be in Kelvin. Okay, if you will find also additional problem, you may try them for exercise. Thank you. Have a great day.